Give the magnitude and direction of net force acting on raindrop falling with constant speed, a cork of mass 10 gram floating on water, a kite maintained stationary in the sky, a car moving with constant velocity of 30 km per hour on straight road, a high speed electron in space far from the gravitating objects and free of electric and magnetic fields. Let us see the answer. So in the first case, the raindrop is falling with a constant speed in a constant direction, so its acceleration is 0. So here the speed is constant, so if speed is constant, that means acceleration is 0. So if acceleration is 0, then we know force is equals to mass into acceleration, and that is 0. So force is also 0. In the second case, we have seen the cork is floating in the water. So if the cork is floating in the water, then its weight is balanced by the upward buoyant force. So we should know this. Suppose it is floating in the water and its weight mg is acting downwards, and force of buoyancy will act vertically upwards. So these two forces balance each other. So the net force on the cork will be 0 again. Now the next case, the kite is maintained at a rest. So in that case also net force is 0. Because the kite is maintained at rest, there is no velocity, there is no acceleration, so there is no force. Next case, the car is moving on a straight road with constant velocity. Constant velocity meaning 0 acceleration. If there is no acceleration, then there is no force, because force is equals to mass into acceleration. So the force exerted by accelerator is balanced by the force of friction between tires and the rough road. This is for the force exerted by accelerator. That is also balanced by the force of friction between the tires and rough road. Last case, the electron. So electron, surrounding the electron, there is no field like gravitational field, electric field or magnetic field. So if there is no fields, then there will not be any force. So the net force is 0 on the electron. Give the magnitude and direction of net force acting on a stone of mass 0.1 kg just after it is dropped from the window of stationary train. By Newton's second law, the net force F is equals to mass into acceleration. Here m is 0.1 kg and acceleration is 9.8 meter per second square. Therefore, force is mass into acceleration 0.1 into 9.8, that is 0.98 Newton vertically downwards. So we are in a stationary train and we are just dropping a stone outside, which is of mass 0.1 kg. When we are just dropping, there is only one acceleration, that is acceleration due to gravity. So there will be a net force, that is equals to mass into acceleration. Mass is 0.1 kg and acceleration is 9.8 meter per second square. So force is 0.98 Newton, that is vertically downwards in the same direction of acceleration due to gravity. B. The same stone just after it is dropped from the window of train running at constant velocity of 36 km per hour. No force acts on the stone due to the motion of train at constant velocity. Net force is same as that of in case A, that is 0.98 Newton vertically downwards. So here our train is moving with a constant velocity. If it is moving with constant velocity in a horizontal direction, then there is no acceleration. If there is no acceleration, because of that constant velocity, there will not be any force. Okay, that is force is equals to mass into acceleration. If acceleration is 0, then because of that horizontal velocity, there is no acceleration, and we are dropping it outside. If we are dropping it outside, as soon as it is dropped, then gravity, force of gravity acts, that is because of acceleration due to gravity, that is mass into acceleration 0.1 into 9.8, that is 0.98 Newton, that is acting vertically downwards. See, the same stone just after it is dropped from the window of train accelerating with 1 meter per second square. When the train is accelerating with 1 meter per second square, an additional force F dash is equals to mass into acceleration 0.1 into 1, that is 0.1 Newton, acts on the stone in the direction of motion of the train. But as soon as the stone is dropped, the force F dash no longer acts and again the net force on the stone is mg, that is 0.98 Newton vertically downwards. So now our train is accelerating with 1 meter per second square. So our train is accelerating with 1 meter per second square, and when it is accelerating with 1 meter per second square, there will be a force acting on that stone, that is mass into acceleration, because it is in the train which is accelerating with some acceleration. So there will be force on the stone also, that is mass into acceleration. Mass is 0.1 and acceleration is 1 meter per second square. So that force is 0.1 Newton, and that force will be in the direction of motion of train. But when we are dropping, as soon as the force stone is dropped, that F dash, that is 0.1 Newton, which was because of that accelerating train, will not be acting. Okay, because it is dropped, so that force will not be acting. So the only force is 0.98 Newton because of acceleration due to gravity, that is acting vertically downwards. So this is the answer for that. Same stone lying on the floor of train accelerating with 1 meter per second square, the stone being rest relative to the train. When the stone is lying on the floor of accelerating train, the gravity force mg acts on the stone is balanced by the normal reaction of the floor of the train. However, the stone is accelerated along with the train. Hence, the net force acting on it is m into a, that is 0.1 into 1 meter per second square, that is 0.1 Newton in the direction of motion of train. So now what they are saying, the stone is lying in the train, lying in the floor of the train. It is at rest. The stone is at rest, and the train is accelerating with 1 meter per second square. The train is accelerating with 1 meter per second square, but the stone is lying on the floor, which is the stone is at rest. Now what will be the force? So it is simple. Our train is accelerating. The stone is lying on the floor. In that case, its weight, the weight of the stone, is balanced by the normal reaction by the floor of the train. But that as the train is accelerating, because of that acceleration, there will be a force on the stone, and that force is mass into acceleration. That is because of acceleration of the train. That is, it is accelerating with 1 meter per second square. So it is 0.1 into 1, that is 0.1 Newton, and it is in the direction of motion of the train. That acceleration is the direction of motion of the train.